So today we're on the last checkup in geometry pace 117. Page 42, problem number 1. We are given these lengths of this right triangle. We're told to find sine of angle B, or sine B, and then the measure of angle B. AC is this here, so that's where the 3 goes. AB is 12. Now this is a right triangle, so which one of these is the hypotenuse? AC, BC, or AB? It's AB. I remember that sine is, how do I remember what sine is when it comes to adjacent side, opposite side, hypotenuse, all those things? We want to use the SOHCAHTOA. So that helps us remember. So I can immediately think of sine is opposite over hypotenuse. So if I want to find the sine with respect to B, I go with the opposite side over the hypotenuse. So that's 3 over 12. So when I do 3 over 12, 3 divided by 12 is? What is it? What do you get? 0.25. So yeah, you should get 0.25, and then you go ahead and add the extra. So you get 4 decimal places. Because I need to look this up in my table. When I look it up in the table, do I find 0.2500 exactly in the table under the sine column? You will find that you do not find 0.2500. So now you have to decide, well, what's it closest to? Which one do you think it's closest to? Looking at your sine column, you find a couple of options that it falls in between, but which one of those is it closest to? It's closest to 0.2419. You see that? You could have went with the other one, but that's just a little bit further away. If you then put your finger across the table and you see that that corresponds to which angle? You find that that corresponds to angle 14. So 0.2500 closest to 0.2419, and that corresponds to 14. So that's how you do number 1. Number 3, I'm given different measurements. Number 3, I'm given AC is now 16 and BC 15. I don't know the length of the hypotenuse. So when you don't know the hypotenuse, which one of the functions will you use? Trig functions. Sine, cosine, or tangent? Well, it's got to be tangent because tangent is opposite over adjacent. So if I'm looking for tangent B, that's here, I go to opposite over adjacent. That's 16 over 15. When I do 16 divided by 15, what do I get for the answer? Do you get 1.0667 when you do that? So 1.0667. Now I need to find the measure of that angle. So look up tangent under the tangent column and I try to find 1.0667. Do you find 1.0667 exactly in the tangent column? You do not. What do you do? Do you give up, go home, close up your pace, just call it a day? No, you wouldn't do that, of course. You'd look for whatever it's closest to, and you find that it's closest to 1.0724. It's pretty close to that. If you look at where 1.0724 is in your column, you go across the corresponding row and find that that corresponds to which angle? Angle 47. So 2 and 4 is the same as what we just did. You're going to use more cosine functions in those, but it's the same idea. Number 5. BC blank. AC 5. Measure of angle A is 44. I'm supposed to find BC for number 5. I'm given AC is 5, measure of angle A 44. If I look at my right triangle, I see AC, that's the 5 that I know. Measure of angle A 44. So I know this angle and that side, but I'm supposed to find this side. Which trig function would help me find this side when I know this side and that angle? Sine, cosine, or tangent? It would be tangent. So tangent of A is equal to the opposite over the adjacent. What's the opposite? That's BC over adjacent, that's AC. I know AC, and BC is what I'm trying to find, so this is working out pretty good. So then I'm going to need to find tangent of 44. BC is still my unknown, and AC is 5. So here, I'm going to use my trig table. This time I'm going to find the angle 44, and then go over to the tangent column and see what the number is there. You look at your trig table, find the tangent column that corresponds to 44, and what do you see is there? Do you find 0.9657? That's still equal to BC over 5. This becomes that. Now I need to get BC by itself, because that's my unknown. That's like the x of the problem. So I multiply both sides by 5 to do that. The 5's here will cancel. And now my BC is by itself. And what's 5 times this? You punch that in on your calculator, and you should get 4.83. So what did I just find? I find that BC, this length, is 4.83. This one was 5. That makes sense what you're doing there? So it's a similar thing for 6, 7, 8, and 9. Maybe let's try one more. Let's do number 8. All right, this is page 42, number 8. I'm given BC is 25. AC I don't know, and I'm given measure of angle A. Which trig function would I use if I know this angle? I know this side, but I don't know this side. Right, that's going to be the tangent again. So tangent of A is BC over AC, because it's tangent of A is opposite over adjacent, is what we have here. I know that BC is 25. AC is my unknown, but I also know that tangent of 20 is my angle. So then I look up 20 in my trig table, go over to the tangent column, and I find what number is under 20 in the row 20 for the tangent column. That is 0.3640. So essentially I now have 0.3640 is equal to 25 over AC. Now I have to do some figuring to get AC by itself because it's in the bottom. I would multiply both sides by AC. You could think of AC as if it was an X. You could easily write this problem the same way. This could be an X, and I could be solving for X. So I multiply both sides by X. That's my unknown, because I could let AC be X. Now I have 25, because these canceled. Now this is simple to solve. I divide both sides by 0.3640. 0.3640. And what do you get when you divide 25 by that decimal? You should get 68.68. Is that what you got? So that solves number 5 and number 8 on the checkup. Now let's dig into the help sheet, the study sheet for this coming up test. Gives you some be able to's, be able to do this, be able to do that. The first thing is be able to simplify radicals. So if you flip back in your PACE, page 16 on that checkup, if you look back on page 16, you'll see that section at the top of the page on page 16, simplify radicals. That was back when we were simplifying something like this. Square root of 48 is on that page. And then you want to look for factors, but square rootable factors, if that makes sense. So I know that 16 times 3 is 48. But I also know that square root of 16 is what? 4, right? 4 times the square root of 3. Remember doing that? So that's that section of simplifying radicals. So those are great examples that, again, if you had trouble, rework those problems. Look back in the PACE where it showed you how to simplify radicals before page 16, because this is the checkup. The next one is use a proportion to find unknown lengths in similar triangles. Use a proportion to find unknown lengths in similar triangles. Where do I find that? Oh, that's on page 15. Problems 2, 3, and 4. The instructions say find the unknown lengths if triangle ABC is similar to triangle STR. So those are similar triangles. You were given 4 of the lengths, 2 from one triangle and 1 from the other similar triangle. So you create a proportion to solve for the missing length. If you look at those problems, you'll see number 2, AD is 5, RQ is 10, AB is 8, RS is unknown. So remember, you set up a proportion for that. 5 over 10 equals 8 over x. And then just solve for x by cross multiplying. Simplifying it down, and you find out your answer for x. Also, be able to find the geometric mean, which is the x, in a given proportion. So that looks like problems number 5 through 12. It says find the geometric mean between these two terms. Do you remember what that means to find the geometric mean? If you're given 45, comma, 5, the geometric mean meant you had this proportion going on, and the x is here and here, here and here. So the 45 goes there, and the 5 goes here. That's a proportion, and the mean is that x. So you're solving again for that unknown x. Remember, these are the ones where when you cross multiply, you get x squared equals, and then 45 times x is 225. And in order to solve for x, you have to take the square root of both sides. This simply becomes an x, because square root of x squared is x, and square root of 225 is 15. Remember those? There are several problems there, 8 different ones, and then back early in the PACE, but it's all the same thing. Just remembering how to set up for the geometric mean would be the thing to lock away. Put it in here. Know what to do. Next section. We're turning now to page 29, the checkup on 29. Use the Pythagorean theorem to find unknown lengths of sides of right triangles. So let's flip to page 29 and 30. That's where we're headed next. That's the next checkup. And you'll see that's the first section here at the top of the page. Use the Pythagorean theorem, which is, what's the Pythagorean theorem again? Are you able to just, does that come right to mind the moment you think about Pythagorean theorem? Or do you have to hesitate to think, what is that again? I've been writing it like this: c squared equals a squared plus b squared. Remember that? So again, go back and practice those. If there's any of those problems that you're unsure about, you don't know what to do, rework them, practice those. On page 29. The next section is use the 30-60 right triangle theorem to find unknown lengths of sides of right triangles. That is on page 30. You've got a 30-60 right triangle drawn for you up here. Do you remember the 30-60 right triangle theorem? What does that tell you? Do you remember this? B, we're losing our marker. B equals A square root of 3. And C equals 2A. Those coming back to you? This is what you would use to solve for 30-60 right triangles. Now, you don't have to use the Pythagorean theorem for these. You have these shortcuts. So if you're given A, for example, and you need to find B and C, one step at a time. If you're given A, that's simple. If you're given something else, you may have to do a couple steps extra to get your result. But again, you get to leave these answers on this page, the radicals in the simplest radical forms. That means you can leave your square root in the answer. It may be part of a fraction, so that means if you have a square root and the denominator of your fraction, should you leave it there? That isn't considered simplest form, right? You need to move it that way it's to the top. So don't leave radicals in the denominator. All right, the next section is using the isosceles right triangle. That's just the next section on page 30. So this is a great checkup. The checkup on 29 and 30. Great problems to be going back and practicing, making sure you know how to do these. Questions about that so far, either of those two things? I guess we should probably write down, what does the isosceles right triangle theorem give us? This one is 30-60. The isosceles is C equals A square root of 2. Any questions so far? So again, go back and make sure that you review those theorems to be sure you have everything available to you. You want to have all those theorems tucked away in your geometry toolkit so you can reach in, pull those out as you need them. So you can solve for these unknown lengths of right triangles. Be able to do the page we just did, page 42, finding trig ratios and measures of angles, or unknown lengths of right triangles. The next section on the bottom of our study sheet tells us to memorize and know how to apply these theorems and definitions we've learned in this pace. So for example, starting on page 6, simplest form of a radical. There's a little box on this page that I'm referring you to. So that's what that means when it says simplest form of a radical box. And the 3 examples is example A, B, and C on page 6. So that's a great page to review. It just helps you know, how do I know when my radical is in simplest form? So if you're not sure, this page tells you step by step what that looks like and how to get there. And then page 8 is theorem 92. Remember that? So theorem 92 is where you're drawing an altitude, and that divides one right triangle into 2 right triangles. If the altitude is drawn to the hypotenuse of a right triangle, then the 2 triangles formed are similar to the right triangle and to each other. Very useful theorem. Theorem 92. Let's see, what's next? Then just keep turning pages. The corollary 1 and corollary 2, you need to be able to know how to apply these theorems when you're working problems. Then page 13 is where we come across construct the geometric mean. We looked at that. Pythagorean theorem, theorem 94 on page 17. And then there's converse. That's on page 20. And then 3060 right triangle theorem, we just talked about that. And isosceles right triangle theorem, we just talked about that. And then our trig ratios and our SOHCAHTOA problems on page 37. Be able to use the trig table to look up whatever you need to know, whatever's missing to help you find answers. Any questions about any of that? Does that all sound like I basically understand all those topics? I feel like I'm going to be ready. A little bit more preparation maybe. I would say definitely finish the checkup and the self-test. Once those are done though, then you're ready. You can do that any time. The self-test in this pace starts on 44, ends on 47. Covers all these topics that we just did. So truly, now one thing we didn't talk much about in this review that we just did was constructing, if you look at page 45 in the self-test, for example, there's two of those constructions. Do you need to be able to do one of the constructions? I just barely mentioned it. It was on our list. Construct the geometric mean, page 13. That's what that's talking about, how you construct that. So page 13 and on the self-test, page 45 at the top, that's what you're constructing here. It says complete these constructions and you've been given these lines, you're constructing the geometric mean. Any questions about the construction? Wait, that means you also need to bring a compass and a straight edge for the test? Yeah. Gonna have that handy? Oh, good.